from Gulbarga, Karnataka. I have completed my BTech in the year of 2020
Okay.
in Upper Institute of Engineering and Technology, Gulbarga.
Okay. So, what are the skills that you have developed in the verification domain?
The verification domain, I have developed HDL, HVL,
Okay.
and tools like Notepad++.
Okay. So, you know about the weighted codes and non-weighted codes, right? What are the difference between weighted codes and non-weighted codes?
Um, okay, like 2 to the power of like, you're saying like that, right?
Yeah.
Yes.
Yeah, tell me, like, what are the weighted codes and non-weighted codes?
Weighted codes in the sense like something will do like power on it. Weighted.
Okay. Okay. Non-weighted.
Non-weighted in the sense we cannot do like we cannot do that in a way, without power.
Okay. So, could you give examples of such codes?
Codes. Okay.
Yeah, like,
Codes I think I don't know.
okay. You know about BCD codes.
Yes, BCD codes.
Then what
Binary
about,
code.
yeah. So that is weighted or non-weighted?
Binary code. Yes, it's a weighted.
Okay. What about XS3 code or the gray codes?
Access 3 code.
Is it weighted or?
Access 3 code. Okay. No, it's not weighted. It's like 3 will do now. Like,
Okay. So, do you know how to implement the muxes from the gates? Like suppose I need to implement 2:1 mux from AND gate. Is it
yes.
possible or could you,
Yes, it's
could you
possible.
show me? Like,
Yes. Can I show my screen?
yeah, you can
Present my
share.
screen?
Yeah, you can present the screen. Yeah.
Is my screen is visible, right?
Yeah, it's visible. Yeah.
Hello?
Yeah, it's visible.
Hello?
Hello.
Hello,
I'm
sir?
audible, right? I'm audible, right, Rajat? Hello. Hello.
Yeah,
Hello?
both of you are audible.
Yeah.
Yes. Okay. And my screen, sir?
Yeah, it is visible. Yeah, it is visible.
Uh, my screen is visible, sir?
Yeah, Nivedita, it's visible. Rajat, could you confirm our rules?
Okay, okay.
Yeah, it's going fine.
Mhm.
So yes, like this is a 2 is to 1 marks, and
Okay.
this is a Boolean expression of this.
Mhm.
Yes, we can do by using 2 is to 1 marks. I mean,
Okay. Can you show me the connections on the mux, like how AND gates will be implemented? Like what will be the inputs and what will be the select lines on the mux? Like you have I0 and I1, right?
okay,
So where you will be connecting the inputs A and
yes,
B, and where what will be the select line?
yes. So select line will be the A here,
Okay. Okay.
and I this is a basically 0, and this is a B.
Okay. How you decided like from the Boolean expression or it from directly from the truth table?
Uh,
Why you are connecting the
so
I0 as 0? Yeah.
yes, I have connected to the like what truth table.
Okay. So could you explain like how you have connected it? Like on what basis you made the
Yes, sir.
decision?
Okay, like I have made like this is a iron gate. I have the truth table here. So
Mhm.
like what I have did, this is a I0. Basically, I can just see here,
Okay.
and this is a I1. I just okay, and that mux. The function of the 2 is to 1 mux is y is connected to 0 when the a equals to like 0.
Correct.
Y equals to 1 when the a equals to 1. So this is the 2 is to 1 marks, right? Here now what I have did uh, if a equals to double 0, then the y should be 0.
Mm.
Then b
Okay.
equals to like b is inverted of this, not inverted, like b 0 1. So it has like 0 1, right? So I have connected b here. A is a select line, so that's what I have just did like this.
Okay. Okay. So you know about the Karnaugh mapping, right? K maps. What is the major advantages of the K maps? Like why we are using it in the digital electronics?
Yes, KMAP. By using a KMAP, we can implement anything. Like it's a easy method to do. Uh, mm, yeah, it's a easy method to do. Like sum of the product of the sum.
Okay.
And we are seeing. Sorry, you are saying the drawbacks. Huh?
No, no, the advantages. Like
Advantages. Okay.
yeah.
Advantages. Yeah, we can do easy method by converting the truth tables,
Okay.
and mm, yes, only we can do about up to like 3, 4, 8
Mhm.
K max, or 5 is not possible in that.
Okay. So in order for higher bits, another mapping technique is there, right? You know that mapping technique.
Sorry, sir.
For higher number of bits, there will be another mapping technique. You do you know that mapping technique?
Higher technology. No, sir, I don't know.
Okay. Okay. So do you know how to implement 5 is to 1 mux from 2 is to 1 mux?
5 is to 1 max.
Yeah, from 2 is to 1 mux.
Okay, let me try once. Hmm. No, sir. I don't think so.
Okay, so you want to give the interview?
We can implement by using enable signal, but I don't know. Like, don't have any idea about it.
Okay. Okay. So what is the difference between combination circuits and sequential circuits?
Yes, the combinational circuit is like the the output enable signal, but I don't know. Like, don't have any idea about it.
Okay. Okay. So what is the difference between combination circuits and sequential circuits?
Yes, the combinational circuit is like the output which only depends on the present input in the combinational circuit, where in a sequential circuit where the not only the it will not only depend upon the present input, it will also depend upon the previous outputs, past
Okay.
outputs. So
Okay.
yes, and the combinational circuits are of example half adder, full adder, mux, demux, encoder, decoder, and then the sequential counters, registers, flip
Okay.
flop, latches. Yes.
So what is the difference between an encoder and a priority encoder?
Encoder and a priority encoder.
Yeah.
Encoder is like mm, encoder have mm, n number of inputs and m number of outputs. And
Okay.
here, yes, and here select lines also will be there. And in the priority encoder, what will happen? Like if majority it will take, which is the highest ones.
Okay.
Yes, this is a what I mentioned.
Okay. So difference between latches and flip-flops?
Latches and the flip flops. Okay, latches and the flip flops. Okay, latches are built from the gates, and the latches have it's a basic storage element. First thing, latches is a controlled by an enable signal. Latches does not require any clock here. And coming to an flip flop, it has an it has a clocks. And flip flops are built with flip flops are built with a latch, and flip flops are also um, controlled by a clock. So this is the major difference here.
Okay. Which will be faster, whether it's latch or flip-flop in terms of operation?
Yes, flip flops is the fastest because clocks are connected simultaneously, right? So yeah,
Okay. What are the applications of flip-flops where you will use?
applications of the flip flops.
Yeah.
Um, flip flops. We'll be using the counter.
Okay.
Yeah.
Okay.
Um, mm, we'll be using in the gates also. We can use.
Okay.
Uh, yes, I mean this much.
Mm, then do you know about the race around condition?
Yes.
Okay. What is that race around condition?
Race around condition will happen in a JK flip flop. Uh, yes.
Does it always happens in the JK flip-flop or?
Race
I'm,
around.
yeah, just not with respect to flip-flops. You just tell me with respect in general race around condition. What is race around condition? Either in terms of programming or in terms of the flip-flops. Like what will happen?
Okay. Race around condition will happen in a both flip flops and programming also. If something like sudden change,
Mhm.
like a 0 to 1 or 1 to 0, it will be not stable, right?
Okay.
0 to 1, 1 to 0, it will be changing continuously. So to that, to avoid that, we'll be using a master flip flop there. Um, yes, this is one condition.
Like how you will avoid it, the race around condition, if in case of flip flops.
Okay.
Like how to avoid the race around conditions in flip flops.
In JK, if I say JK, so I'll be having like and Q's memory state, right?
Okay.
So toggling it will be there.
Mhm.
To avoid that drawback, we'll be using master JK flip flop there. By using a clock, you can also avoid that one.
Is it a master JK flip flop or master combination of master and slave JK flip flops?
Combination of master JK flip flop, yes.
Okay. 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 So yeah. What is the excitation table or the what do you mean by excitation table? What it will give? The significance of the excitation table.
Excitation table, okay. Mm, we'll get the outputs there X values
Okay.
and again you say character, right?
Yeah, characteristic table, excitation table, characteristic table.
Okay, characters means we'll go through the truth table. By truth table, we'll get a characteristic table. By yeah, so we'll get the combination of seven. Yes.
Okay. So what do you mean by synchronous circuits and asynchronous circuits?
Yes. Synchronous means the clocks in the synchronous the clocks are connected simultaneously, wherein
Okay.
the asynchronous will be not connected simultaneously. Here in a synchronous, it will be a slow compared to the asynchronous, and it also acts as an flip flops. Um, and in a asynchronous, it acts as an a latch. Immediate values will be changed in the input, and so that output also changes, of course. And here in a asynchronous, it will be a fast compared to the synchronous because there is a no need of a clocks not connected simultaneously there.
So you know about the synchronous reset and asynchronous reset, right? What is the difference? Synchronous reset and asynchronous reset. What will happen here when you apply? When we say we are applying a synchronous reset, what does that mean? And when we say we are applying asynchronous reset, what does that mean?
Okay. Synchronous reset. Reset for the both it will be like empty state like zero should be there, and here the synchronous if I applied there means synchronously it will be connected there, or synchronous means like I don't know.
Okay. So you know about FSMs, right?
Yes.
Okay. So what is Mealy model and Moore model?
Yes. So, Mealy module says like the function of the output not only depends on the present input, it also depends on the present state. And
Okay.
in the More module, you have the output, the function of the output, which only depends on the present state. So this is a major difference here. And the module it consists of n equals to n plus 1 states, and in the Mealy module, it consists of n state equals to n state.
Okay. So yeah, what do you mean by Johnson counter and the ring counter? The difference between Johnson counter and the ring counter.
Johnson counter.
Suppose you have 4 bits inputs you are giving to the counter. How many possible states will be coming in Johnson, and how many possible states will be coming in a ring counter?
Okay. So, in a Johnson counter, I think I did not study this Johnson and ring counter actually, but I just give a like little glance about it.
Okay. Just look into those things also. Okay.
Yes.
So then, what do you mean by setup time and hold time?
Yes, in a setup time is like the amount of a time required of the flip flop to be stable before it should be stable before the clock age,
Mhm.
and in a whole time the minimal amount of a time is required after the clock age. It should be stable after the clock age. Yes.
Okay. So whether it will be applicable for input signals or only the output signals? What, like for all the signals?
Yes, it will be applied to all signals.
Okay.
All signals in the sense
Okay. So what do you mean by metastability? Metastability
data stability.
So
Okay.
in flip flops.
stop sharing, stop present. Yeah, it is fine.
Metastability when it will happen when the both the clocks input clocks and the output clocks it will be not in the same edge. It will be like unknown state, right? It will happen like that, metastability.
Okay. How will you avoid the metastability?
I did not study that.
Okay. So you know about Verilog, right? Why we will call Verilog as a HDL language?
HDL language.
Yeah.
Okay. Mm, so what Verilog is like totally hardware description language, and here mm, yes, I don't know.
Okay. What are the data types present in the Verilog?
Data types present in a Verilog: reg, wire,
Hmm.
and yes, only two are there.
Only two data types.
Mm,
What about the integer?
is integer,
Floats.
real, floating.
Okay. So difference between wire and reg.
So yes, so reg is like it holds the value until we put another value to it in the, to the reg, and the default value of the reg is x. And
Okay.
coming to the wire is like it does not, it will not hold the value. It is an intermediate connection between the one component to the other component, and it acts like a wire also. And the default value of the wire is a z. So this is the difference between, and both coming to a Verilog, both has in two states, 0 and a 1.
Oh, X is not possible in wire.
No, it will be created a high impedance value.
Okay. So we can't drive like X in the wire. Like suppose you declare one signal as wire, and nowhere you will be seeing X in that X propagating in that particular wire.
We can, but I did not try that. I did not try that.
Okay. So what is the difference between the blocking statements and the non-blocking statements?
Okay. Blocking statement in the sense like blocking statements are always assigned by equal operator here, and it will be executed one after the other in a serial, sequentially it will be executed. In a non-blocking, it will allow the assignment to be scheduled without blocking the statements or the assignment, and it will be it will be executed in a parallel.
Okay.
Yes.
Then in order to model the sequential circuits, whether you will use blocking statements or non-blocking statements.
Sorry, sir, I did not get you.
In order to model the sequential circuits, whether you will use blocking statements or non-blocking statements.
In a sequential circuit, we'll be using non-blocking. Yes,
Okay.
we'll be using.
So what will happen if you mix both blocking and non-blocking statements?
It will get a runtime check error, and it will get something known called as meta. It's also get like meta stability. It's will get, I think.
Okay, okay. So you know about the time scale directives, right?
Time scale directives. Sir, if you give hints, I can just give.
The time scale directive, like the simulation time scale, 1 nanosecond by 1 picosecond. Those
Yes.
things. What does those things mean? The time scale directive, what it will tell?
At 1 nanosecond, you will get something. You have finished this code at 1 nanosecond. If you give the delay to it, like you will get something else to it.
Okay.
I don't have proper definition of that, but
Okay.
I just
Yeah, look into those things also.
yes.
Then, so difference between task and function in the Verilog.
Yes. So difference between the task and the function. So in function, we cannot call a task because it consumes a time here. So yeah, and in a function, you have only one argument, and you have only one values. One values in the sense function can call a function.
Mhm.
Okay, and function does not contain any time controlling delays there, and for join was like that. And not coming to a task, it call many functions inside that. Task can call many functions. Task has a many timing control, timing delays, fork joins, parallelly it will be there. And it consists, it has an argument like input and output arguments, in-out arguments also there. Yes, this is a task and functions difference.
Okay. You know about case, case X and case Z?
Yes, K6 and KZ.
Okay. Yeah, what those things will do?
Okay, case X, what it will do, like in a case X, it will be not including X and Z here, and in a case Z, it will be it will be including. It will be including or not including. I don't remember the case Z.
Okay. Okay. So what about this parameter and def param? What does those things mean?
Okay, parameter. Def param will have a multiple statements, multiple modules. Def param includes, and coming to a parameter is local to the variable where it's illegal to the module of runtime check.
Okay. What else? Okay. SystemVerilog. You have idea about SystemVerilog, right?
Yes.
What is the main reason we are moving from Verilog to SystemVerilog? Why? Why is that?
To verify, to reuse the components, for reusing the components. To verify something, a schematic diagram or code. It's a hardware verification language, so we are just verifying.
Okay. So in SystemVerilog, what are the data types present?
Data types present. You have 2 states and 4 states. First thing, and second thing, in the 2 states you have a bit byte, long int, short int, int, and in coming to the 4th state, you have a reg wire, long int, logic, and yeah, this much in a 4th state.
So difference between logic, reg, and wire.
Logic, reg, and wire. Okay, logic is an improved version of a reg, and logic cannot be driven multiple structure. Logic can have continuous assignment. It may yes, it will be having continuous assignment, and it is a default value of a 0 and a 1. And coming to an wire and a reg, like all 3 are the unsigned data type here.
Okay.
And here next coming to a reg, it also hold a default value of x and the default value of a wire is a z,
Okay.
and in it holds 01xz. And here in a wire it will be holding like 01xz. Yes. So this is the difference.
Okay. So you have the scheduling regions in SV, right? You know about the scheduling regions, event scheduling regions.
No, sir. I did not study regions. I just know Verilog. I forward that.
Okay. Okay. So you know about mailboxes, queues.
Yes.
Okay. Difference between mailbox and queue.
Okay. Mailbox is like mailbox is a mechanism where the communication will be happening in between the one process to the other process. Exchange data it will be there. And in a coming to a queue is also like communication, but queue won't support the mailbox. Queue won't have a mailbox. It's like adding and removing the elements. That's it. Queue. Push pop print, it will not support that. So queue also has a non-blocking, you can say, and the mailbox is a blocking statement. So this is the difference.
So difference between byte, okay, and bit 7 down to 0. What is the difference between these two?
Difference between byte.
Yeah, byte, and suppose I will declare one variable as byte A, okay, and another variable as byte 7 down to 0 B. What is the difference between these two A and B variables?
Okay, let me write once.
Yeah, bit 7 down to 0 A and byte B.
Bit 7 down to 0 A and byte
Byte B. What is the difference? Yeah, what is the difference between these two variables?
Okay, so here A consists of 8 bit of
Okay.
8 bit in the sense 1 bit.
Okay.
B means like it consists of 8 bits. 8 bits.
Yeah.
Yes. So totally it will be like
So 1 byte is 8 bits only, right? So what is the difference?
1 byte is 8 bits. Yes. Bit is a like unsigned data type. Byte is a signed data type.
Okay. Okay. So in SV, you know about the polymorphism concepts, right? Polymorphism, the
Yes.
function overriding. What do you mean by polymorphism?
So polymorphism means it's an ability to have an object in a many forms. So
Okay.
like for example, if I take an example like this, so you have a base class, right? This is a base class, and it consists of many block diagrams. It consists of many things, many forms. You through the base class, you can consider the many forms like in a derived class.
Okay.
Yeah, by using a virtual method, you can connect the other polymorphism.
Okay. So when we will be using dynamic arrays and when we will be using the associative arrays?
Okay. Dynamic and associative array. Dynamic when the memory will be allocated before we have to use in a dynamic. In the associative array, it's like we need to allocate that. We need to allocate that after the memory.
Okay. Okay.
So in a dynamic, you have a new format, new method, new size, delete. In a dynamic, you have many more things method.
Okay. So what is function overriding and overloading? Any idea about these things?
Function,
Overriding and overloading.
overriding and overloading.
Overriding and overloading.
I don't know.
Okay. So what is the requirement of constraints? Why we have constraints?
Constraints, means like to overcome, to control over on the randomization.
Okay.
So you have many types of constraints to overcome.
Okay. So, and you heard about the system task, right? Like dollar strobe dollar right.
Yes, yes.
Okay, what is the difference between dollar strobe dollar right and dollar display?
Okay. Coming to a dollar display, like it will be executed in active region first, and it will be displayed the expression, the values, immediate values. It will be displayed. Coming to an dollar right. So dollar right, what it will be do? It will be executed in the postpone. In an active region itself, and in the dollar right, it will be like displaying only once. And the dollar right, it will be displayed at the end of the black slash n. It will be
Okay.
end of the simulation.
So what is virtual function?
Virtual function. So virtual function is like connecting between the module and the class.
Then what is interface? Then virtual interface.
Yes, it's a virtual interface is like same. It's connection between the module and the class. Right?
Okay. So you know UVM things.
UVM I did not study it actually. I just read about the architecture
Okay.
and the phases. That's it. Phases in the
Phases.
sense like.
Okay. So why we are moving to UVM? Like since we have a SystemVerilog, right? Why there is a need for UVM? What are the advantages of UVM? Like why you are moving from SystemVerilog?
Yes, UVM. Okay. UVM is like why we are using the UVM, because it's not a language, it's a methodology. First thing.
Okay.
Second thing, uh, you will get something the standard. It has rules to be done there. The UVM. And for the scalability, for reusability, also we can use the UVM. We'll get some reporting messaging.
Okay. So you said you read about phases, right? Phases of the UVM.
Phases I have read. Yes,
Okay.
I have read, but not depth I have read.
Okay. Okay. So okay, in your resume you have updated about the APV protocol. Okay. So what is APV protocol? Like, why is it required?
Okay. Okay. So here coming to my project is like Amba APB now. APB, like from first onwards I have to explain. So
No, just tell me what is the use of the APV protocol? That's like
okay,
where we will be using the APV protocol.
okay. Let me draw something. Okay.
Is the screen or
Oh yes, sir.
okay.
Sorry, sir. I'm really sorry. It's visible.
Still load. Yes, screen is yeah. No, just explain in terms of words. I no need to draw the FSM and all. So,
Okay, let me explain you. Okay, APB, why we are required APB? Because it's a advanced peripheral bus, as you all know this. And the feature of the APB is like it's a low cost, low peripheral, and it consists, in order to communicate from the one IP to the other IP, we need this peripheral first thing, APB.
okay,
So, and it's an unpipeline protocol, first thing, and every transfer take at least 2 clock cycles here, in the APB, and one
okay,
master, one slave at the same time should be available here.
okay,
This is what here in the APB features. And coming to an state machines, like you have a 3 cycles, like ideal, setup phase, and the access phase.
okay,
So in the ideal, P select, what the P select will do, it will select the slave.
okay,
And the P enable, it is to enable the slave.
okay,
P select equals to 0 and P enable equals to 0 in the ideal state, basically.
okay,
And if the P select wants to take a transfer, then it goes to the ideal state. Then afterwards, in the ideal state, in a setup phase it will go, in a setup phase, when the P select equals to 1, that time what will happen, in the setup phase, you have one condition that only one transfer should be there.
okay,
Only one bus cycle should be transferred in the setup phase. Then it
okay,
goes to the access state. Then afterwards in access state, when the P select equals to 1, here the P enable equals to 1 is asserted here. When the
okay,
P enable is asserted, what it happens? Yeah, P write and P address, P write, P address, PW data, PR data, and the P ready data should be in the access state, because it will take a transition from setup phase and the setup phase and the access phase. So, okay, and this access state, what it will be? This access state, it will be controlled. It will be controlled by what, some signal called P ready. So when the P ready equals to 0, it should be in the access state itself. So then it goes to the setup phase. And if no, I'm done with the transfer, means I should be going to the idle state. This is the state machine of 1 clock cycle in the APB says.
okay, okay. Have you written any other Okay, that from my side, I think. Yeah.
May I get to know that what I have to improve? Whether I have to.
So, yeah, coming to the digital electronics part, just brush up the basic concepts, especially the sequential parts. Okay. And Verilog, yeah, you can go through the concepts of the Verilog. You know theoretically, but yeah, the practical things where you will be using those things and all, you should. Yeah, those things will come when you do hands-on things. Okay. And coming to SystemVerilog, yeah, you need to improve, I think, SystemVerilog. And UVM, as you said, right? You haven't read the UVM. So once you are good with the SystemVerilog, you just go through the UVM things. Okay. So once you are familiar with these SV things and UVM, then try to learn about the higher level protocols like AHV or AXI, and try to learn one more serial protocols, say I2C or UART. Those are all basic protocols. Maybe you can learn those protocols. As of now, you can send the SystemVerilog parts. Okay. So, yeah. Yeah, hello, Rajat.
Yeah, it's over.
Shall I leave the meeting?
Yeah, it's over. Yeah, Rajat. Yeah. So I have given her the feedback.
Yeah, you can give the feedback also. Okay, you have given.
Yeah, I have given her the. I have given her the feedback.
Okay, thank you so much. Okay, sir.
Yeah, thank you, Rajat. Yeah, thank you. Thank you.